Okay, boys and girls, here's the video as promised. This one will go over all our asymptotes, vertical, horizontal, holes, zeros, x-intercepts, y-intercepts, and the domain. The slant asymptote, which was introduced today, I will do a separate video for that. Alright, so going through this, first things first, you have to factor. So I'm going to factor my denominator. So to factor this, to multiply to get -6 and add to get +5, it would be a +6 minus 1, which is nice, which is what I wanted. So now I can cancel my x minus 1. So remember, when we cancel, it's not 0. I'm actually doing something divided by itself, which is just 1. So if I were to rewrite this function, it would be 1 over x plus 6. Okay, so now let's address the whole portion. So I found that x minus 1 was a common factor. I set that factor equal to 0 and solve. And I get x equals 1. So I will have a hole at x equals 1. To find out that exact point where the hole is, I plug 1 back into my function that I have now. 1 over 1 plus 6. And so I should have a hole at 1 and 1/7. Because my fraction here will give me 1/7. So that's where my hole should be. Okay, now let's go and do the other pieces. Okay, remember, the vertical asymptote is when the function is undefined. That means when the denominator is 0. In all the notes we've done so far that are in your OneNote notebook, I've tried my best to make sure that I'm color coding with what I'm doing to where it pertains to in the function. So here I'm looking at just the denominator. So I'm going to set that equal to 0. Solve for x. X equals -6. Okay, so x equals -6 will be about here. 1, 2, 3, 4, 5, 6. There is my vertical asymptote. Perfect. Okay, next thing I'm going to look at is my horizontal asymptote, which again, I'm looking at the highest exponent of my leading variables or my leading coefficients. So there's no x on top, so it'll always be 1. So as I keep plugging in x values, the denominator is going to get infinitely bigger, which means the fraction gets infinitely smaller, which means that I have a horizontal asymptote at the line y equals 0. And it's because of this. No exponent on top with a variable, so therefore the bottom is bigger. Okay, zeros. Now zeros of the graph, again, and x-intercepts are the same thing. It's when this function equals 0. So I would only be looking at the numerator, sorry. I'll only be looking at the numerator. And here, there's nothing I can plug in to make this thing equal 0. So for this case, there are no x-intercepts. Again, which makes sense because we have a horizontal asymptote at 0, so it won't touch it there. Now, the y-intercept, it's when I'm going to plug 0 in for x. Remember, anything that's on the y-axis, my x-coordinate is going to be 0. So in this case, 1 over 0 plus 6 equals 1/6. So I will have a y-intercept at 0 positive 1/6. So it'll be 0, positive 1/6, which again is about somewhere right there. Okay, so now my domain is going to be from negative infinity to -6, the first break in the graph, right here, union, starting at -6 again, going all the way to positive infinity. So again, there's only one break in the graph, right here, so there should be only one union. Okay, so now, I know that there's going to be a hole at 1 1/7. So let's mark that. So at 1 1/7, which again is very hard to mark because it's so small, there should be a hole somewhere right there. Let's maybe make that a little clearer. Okay, so a hole will be somewhere in this area. Hold on. Oops. Oh, there it goes. So let's try this again. My y-intercept is 0, 1/6, which again is somewhere there, and my hole is at 1 1/7. It'll be somewhere over here. Okay, so because that the green point on the left is higher, because that fraction is bigger than my hole on the right, I know that the graph is going to go something like this. Okay, and then just for practice, I'm going to plug in a couple points left of the vertical asymptote to see what I get for an answer. So my vertical asymptote is at -6, so I'm going to plug in -7. So it'll be 1 over -7 plus 6, which it would be 1 over -1, which is equal to -1. So at -7, I have the point at -1. Okay, so when I plug in -8, the next number, 1 over -8 plus 6, I get -1/2. So that means at 8, it's at -1/2, which means my graph will go like that. So there it is. That's every piece of a rational function except the slant asymptote, which I will make a separate video for when we go over this. Hope that is helpful, and any questions, let me know.